Okay, so the next question that we have on the menu today is asking us to find the equivalent capacitance of the circuit. Answer in, I'm going to assume microfarads because everything else is given in microfarads, and then we got to determine the charge on this capacitor right here. Okay, so there are a couple of rules for finding equivalent capacitance. In parallel, they're very easy. You just add them up normally. So to write this formally in math terms, we have the equivalent capacitance is just the sum of the component capacitances. Now, if we're in series capacitors, is kind of similar to what you would do with parallel resistors. So 1 over... You have to add up the reciprocals of all the components and then take the reciprocal of that result. Okay, so that would be how you find the series capacitor values. Okay, so let's draw out this circuit, or just really draw out the capacitors, because that's what's really important. So here we have 1.41 microfarads. And then we have a little parallel branch where we have 4.63 microfarads on top, and then we also have 3.24 microfarads on the bottom. And then here, kind of looks like a source, but we're going to treat it as a capacitor because it says 7.96 microfarads. Okay, and we're looking for the CEQ across here. So the first thing that we want to see is, hey, don't we got a parallel section right there? Wouldn't that be nice and easy to compress? So we know that this CEQ for this section is going to be 3.24 microfarads plus 4.63 microfarads, which is equal to 787 microfarads. Okay, so we can redraw the circuit as 1.41, 7.87, 7.96 microfarads. Okay, and now we have 3 in parallel. I mean 3 in series. So we can find the equivalent like this. CEQ is equal to 1 over 1.41 microfarads plus 1 over 7.87 microfarads plus 1 over 7.96 microfarads. That whole thing to the power of -1. And let's run that through the calculator and figure out what it is. So we got 1.41, 7.87, 7.96, all reciprocaled, and my final result was 1.04 microfarads. This shall be the equivalent capacitance of the circuit. Cool. Now we want to determine the charge on the 141 or the 1.41 capacitor. And that's fairly simple because we know that the charge on series capacitors is always the same for all of them. Okay, so that's going to be a nice rule to keep in mind. All series capacitors have the same charge. On them. Okay, so we know across this whole thing, we can kind of redraw the circuit as so. So we have a 10 volt source, and here we have just CEQ, which corresponds to 1.04 microfarads. Okay, so we know that the 1.41 is in series with all the other ones. So if we find the charge for the equivalent capacitance of all of them, we know that like one of the series components that originally made it up has to have the same charge on it. Okay, and we know that the charge, the capacitor equation of interest is going to be Q equals CV. So that's capacitance, and this is voltage. So hopefully it should be fairly obvious that the voltage across the entire equivalent capacitor network is 10 volts. So we will have V is equal to 10 volts, and C is equal to CEQ, which in this case is 1.04, I believe, microfarads. So we had, right? 1.04, yep. So we multiply them together, and we can get the charge on it. So Q is equal to 1.04 microfarads multiplied by 10 volts. So it's going to be 10.4 microcoulombs. Okay, because the micro is going to stay. Yeah, so that would be the amount of charge on it, and regardless, because it's in series, we know that like this 1.41 is in series with the rest of it, and all of them together have a charge of 10.41 microcoulombs on them. So all of the series components that make up this entire equivalent capacitor have to have the same charge, assuming they're in series. Like the two parallel things, they're going to have different charges in them, but the equivalent between those two is going to have the same charge Q of 10.4 microcoulombs. Okay, so here, so the above solution is good. However, mention of the fact that all series capacitors have the same charge on them would be good to yeah, it would be good to make the calculation more clear. Awesome. Okay, so I'm kind of running out of time for now. Let me switch over to my cam real fast. So those are all the questions that we have for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and ring the notification bell below. If you're interested in submitting your own questions, please visit the video links in the description, and remember to leave a like and a comment if you enjoyed the video, and if you really enjoyed the video, share it with your friends. This has been Millen from OneClass, and I hope to see you again soon. And don't forget, physics, always a fun time. Take care. Have a good day.